Didn't. Okay, so I have no idea. Maybe it was a coincidence. Who knows? Okay, so the questions we have so far, so we'll start with the first ones. So day number 6 is our first problem. So it was day 6, problem number 8. So problems 7 and 8 kind of go together. So with number 7, you had to fill out this thing. So I'm just going to fill it out with what it should have been. I'm pretty positive. And then we can talk about how that relates to problem number 8. You may have already, I don't remember who asked this question, but you might have already had it answered. I'm still going to go over it just in case. But 99.99999. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then a 4. Okay, so then problem number 8 says the partial sums in problem 7 converge to what number? All right, so in number 7, this was a geometric series, and we had a ratio of 0.9. So this also goes into the question above where it says, how do you determine the infinite sum? Like, how do you know if it's possible? All right, well, the rule tells us that if the common ratio, the absolute value, so it doesn't matter if it's positive or negative, is less than 1, so it's a fraction, is less than 1, so a fraction. All right, then you have a converging number. So then the series converges. And we talked about converging, right? Converging means it has an end goal. And if you look at problem number 7, and it starts off at like 5,000, but then as you go to like the sum of the first 100 terms, it's 7,999, and then at 200 terms, the sum is still at 7,999. All right, so overall, it's eventually going to go to 8,000. So our limit.
You're writing.
You can't see me write. Oh, good job. I forgot to scroll. Good job for reminding me. I was scrolling on my iPad, but it wasn't scrolling on my thing.
Oh, good. I was like, am I the only person not seeing?
No, I see that there's like a bunch of chat happening, but I can't read it because it's really tiny writing. I was just assuming you guys were like talking to each other.
They are.
They are. Okay. I can't make the chat bigger. I can't do anything. I don't like this. It's not very user friendly. All right, so just deal with what you have over there with your chat. All right, but anyway, sorry, I didn't scroll. All right, so here you guys have your, so you can see that your limit is converging to 8,000, right? And if you added up the first 1,000,000 terms, it still would never go above 1,000. All right, so that's kind of, anytime you have a geometric sequence, if your common ratio is less than 1, like the absolute value, so it doesn't matter if it's like negative, that doesn't matter. All right, but if the absolute value of your common ratio is less than 1, then your series is going to converge, and there is actually a formula to figure out what it converges to. So your limit as n goes to infinity of your sequence is going to be of s of n equals your first term divided by 1 minus r. So there you go. So if you were to take the first term of this sequence, calculate the font partial sum of the images, blah, 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 whatever it was. I don't know where the formula went. Oh, 1,000. Yeah. Right. But anyways, so that's how that one would have worked. But it kind of just wanted you to use problem number 7 in order to see that, oh, these numbers are getting really close to 8,000. It must converge to 8,000. Did I answer the questions that we had on problem number 8 on day 6?
Miss Lassie?
Yes.
This isn't really about any of the questions. I was just kind of confused. I have one of the old dumb calculators, and I don't really know how to like use the new equation with it.
Okay. So if you have one of the older calculators, then you can't use the summation. So for those of you with the newer ones, you know that you can do like there's a button where you can get that summation part, and then you just fill out this and you fill out this and then this part. If you don't have one of those calculators, then you can just use the formulas that we learned on Tuesday this week, which are, it's actually on the back of the homework day 7, which are these right here. So if you don't have a fancy calculator, it's fine. All you need is, scroll to the side. You just need this equation and this equation. So those are going to make it so you don't need the calculator anyways. Yeah, so for those of you, like I said, that have that older calculators or whatever, the equations are all you need. And since everything is like your checkpoints, it's not like you have to memorize them, right? You have everything with you, you're taking them at home. So it's not that much more difficult. Actually, it's probably faster to type these equations in than it would be to go find the thing in your calculator and then plug all the information in. All right. Any other general questions before we move on to the next one, which I think our next question is day 7, problem 5. So are there any more questions on, I guess, day 6 altogether, or any of like the topics that we covered in day 6 before we move on to day 7?
In the new calculators, when you have the little pop-up, how do you fill that out?
All right, so once you go, it's like math 0, I think is how you get the thing to pop up. Then you're gonna have to use the number pad, this thing to like scroll. So my calculator is dead, so sorry I can't actually show you. But you use these to like scroll. So like if you want to fill out the top part, you just use this to like go to the top part of it. And that part, you're just going to put in whatever the problem says. So if you want like the first 11 terms, you put 11 at the top. The only part that's kind of strange to fill out is the underneath of the hold on, where am I? That shows that. So we're right here. So the only part that's kind of strange is, so there you have this, to get to this part, you just use the up arrow on your calculator. The below, so to get to the below section right here, you just have to hit the down button. The only weird part is that you're gonna have to put a variable in for the first section. So it's like 2 boxes right here. Oh God, let me just erase that. That looks ridiculous. So this has like 2 boxes.
Charles, if you want to like use Hungry for Lunch at all. Okay.
You just put like I would just use the X. So like when you go to that first box, just use the X button that's right here that you would use to type into like y equals, and you would do like 4x plus 7 or whatever. Just use the X button. It makes it easier. And just scroll. It's not too bad. Just play around with it. The only part that is kind of weird is that the first box, it's like a variable where you have to put like the n, but you don't have to use n. You can just use x if you want to. It's easier. Yeah. So, and any other general questions? These are good questions. I like these questions. Okay. So that means we are doing problem 5. Okay. All right. So problem number 5. So this one is kind of tough. This is a good one to go over because I believe this is an arithmetic sequence. All right. So for number 5, it wants us to determine if it's arithmetic or geometric and then find n. So this one, if we look, all right, 32 to 43, that's 11, right? We added 11. And then 43 to 54, again, we add 11. All right, so this is arithmetic, all right, with a common difference of 11. All right, so the first thing we have to do is we have to make the explicit equation. So a sub n equals, so it's our first term plus our common difference, all right, times n minus 1. And then I would recommend simplifying this. So distribute your 11 and then simplify it so it gets a little bit prettier to look at. And 32. Where is this one? Aha, there it is. So I'm just being lazy and I didn't want to do math in my head. Plus 21. There we go. All right, so there's our arithmetic equation. All right, so now we need our equation for our sum. All right, now we don't know what term number we're looking for yet, so we're just going to kind of generically fill out our sum equation. So our sum equation looks like this. So it's n over 2. We don't know what n is. And then it's the first term, which is 32, plus the a sub nth term. Now, we don't know what n is, so we can't figure out the actual numerical value for a sub n. So what we're going to have to do is basically just put in the explicit equation. So we're going to have to put in a sub n as 11n plus 21. All right, so just remember the formula s sub n equals n over 2 a1 plus an. Is there anything cool happening in the chat? No, you guys are talking about weird stuff. Okay. I didn't know if it was real questions over there in the chat. Oh man, you guys are like blowing up. I'm gonna have to take this off. It's buzzing too much. It's annoying me. Okay. So that's where we're at. Now we just need to plug in our s sub n value so that we can work backwards and solve. So I'm going to erase s sub n right here, and I'm just going to plug in the actual value that it gives me, which is 4407. 4407. All right, now it is just an algebra problem. We're simplifying and we're solving for n. So next we would multiply both sides by 2 to get rid of this. Multiply by 2. That's going to give us 8814 equals n times, and then I'm going to combine my like terms in there. So I have 11n plus 53. All right, and then I have to distribute. Bloop, bloop. All right, so then I have 8814 equals 11n squared plus 53n. Everyone's favorite, it's a quadratic. So I need to move everything over to one side. So I'm going to subtract my blah, blah, blah. All right, so 11n squared plus 53n minus 8814. And then I'm going to use quadratic equation because I don't want to factor that. You could factor it. It's definitely factorable because it's going to come out to a nice number, but nobody wants to do that. So negative 53 plus or minus the square root of 53 squared minus 4ac, negative 814, all over 2 times 11. And when you simplify this, you should end up with 26. So 26 is your n value. So that was
Miss Lasley?
Yes.
So if when I was doing it, I didn't get like plus or minus 26. Like I got 26 and then I got a weird decimal.
Yeah.
Like, so how do we determine that 26 is the right answer?
Could that weird decimal, it would have been a negative number, right?
Yeah, I think so. I didn't write it down.
Yeah, just remember what this is solving for, right? You're solving for the term number of your sequence. Can you have negative term numbers in your sequence?
No.
No.
Okay.
No. This was something other people asked me this because they did some rounding on the checkpoint for last week. So some people did a problem and got like, I don't remember the exact problem, but like say they got like 5.9 or something. And the answer that was actually the correct answer was 6. You can't have a term number in a sequence be the 5.9th term. It doesn't make sense. So remember, we are talking about a sequence of numbers. So you have term 1, 2, 3, 4, 5, 6, and so on. You don't have term number negative 5,000 or term number 4.3. Like those aren't term numbers for a sequence. Like this is like counting. So if you ever get something that is supposed to be a term number, make sure it makes sense. Right? This is kind of going back to like when you were in geometry, if you measured something, so you had a length value and you got a negative length, like that's not possible, right? You can't get a negative length in geometry because it's an actual physical measurement of something. It's the same kind of thing with these things. If you get like a negative term number, like that doesn't exist. So just make sure that your answers make sense with what the problem is asking you to find. Yeah, good question though. Yeah, you obviously are going to get 2 answers for this because it is a quadratic, but only one of them is going to be the correct answer. All right, do we have, I know that one was kind of brutal. Definitely make sure that you're practicing today's, because today is like more practice, like mixed review kind of thing. And I guarantee you there's at least one of them that is one of those arithmetic sequences where you are finding the nth, like trying to find out what n is, and you have to do it every single time you do an arithmetic one. You're going to have to use the quadratic formula to find what n is. It's always going to end up being an n squared. Just like when you're working backwards with the geometric sequences, you're always going to have to use your log properties to figure out what n is. So just be ready for that. All right. Any more questions on day 7? That was our day 7. That was the only question someone asked. Okay. So day 8, problem number 8.
The day of the week was day 7.
Tuesday.
Okay.
On day number 8, I realized that I made a mistake. When I did these ones, I was fixing the worksheets and I accidentally did the wrong problem, and it's now fixed in the OneNote. But sorry about that, guys.
Was that on problem number 8?
Yeah.
Oh, so it might not even really be a question kind of thing. We'll go over the answer.
Go over it. I realized it this morning when somebody asked me about it in a different way than whoever asked about it the first time, but I apologize. I had a bunch of things open and I did the wrong problem in that box. So sorry, guys.
Cool. All right. So this one, you guys had your table of values and I wanted you to answer some questions on it. So first I wanted to know what rate everything was changing. So we'll go over this one real quick. Oh no, there it is. Okay. No, stop. Okay. There we are. All right. So first you had to figure out all the stuff. So your rate is 1.015, right? So remember that at what rate is population of New Zealand growing? R equals 1.015. Rate of growth. Oh, rate of growth. That's weird. Okay, that's what I put. And then my explicit equation is A sub n equals 3566 1.015 n minus 1. And then what year did my population reach 4.1 million? So I did, how did I write this? So I just did 4100. Oh, because it's in thousands. Oh, yes, that is why I only put that. And then I just did equals 3566 1.015 to the power of n minus 1. And then you should end up with, I got 10.37. So in what year will the population reach 4.1 million? So I didn't even finish answering the problem on my answer key. Give me a sec. So that looks like what, 10, we'll say 10, 11 years if we're just going by years. So that's 7, 2002, 2003, 2000. So I think the answer should be 2004. Is that what you ended up getting, Miss Markert, on your answer thing?
Yeah, that looks right.
Okay.
Miss Lasley,
Yes.
why is it just 4,100 as opposed to 4.1 million?
Because it says it's in thousands, right? So in our instructions, it says the population is in thousands. So in 1995, I think there's like a wire that's loose. The population says 3,566 in 1995, but that really means that it's in thousands. So we're going to add 3 zeros to the end. So 3.5 million is what it's actually saying for the year 1995. So 4.1 million, it's in thousands. So that really is going to be 4100. It's just, you got to move the zero. It's just because it says it's in thousands. I know it's kind of strange. But yeah, if you look at 2001, that's saying 3.8 million. Well, 3.899 million. Yeah, so 4.1 million would be 4100. You guys had one pretty similar to this when we did our log unit. It was like the population of Colorado was whatever, and it was like, and it was in thousands like that. I think I tried to, like, it's like a throwback question kind of to what we did in the log unit. It was just kind of funky. Okay. Any other questions on day 7?
Hello?
Yeah. Hey, Charlie.
Oh. Is Mitch. Hey, Charlie.
What's your question?
Is it not reading?
I can't hear you. I can't hear you, Charlie. Do you not have a question? Okay, well, oh yeah, he's lagging. If you think of your question, Charlie, you can type it in the comment in the little chat box.
Miss Lastly,
Yes.
sorry, how did you get 2004 again from 10.37?
Okay, so the n is my number, like my term number of my sequence. So this is saying it's going to take 10 years, 0.37, like 10.37. So if you look at our chart, our first year is 95. And then 2001 is the 7th term of our sequence. So this is saying, so it's not going to happen in the 10th year. It's going to happen in the 11th year. So I just did 11 years past like the start of the thing. And that was 2004. Did I do math wrong? 90. Yeah. Because if 95 is 1, 2, 3, 4, 5, 6, 7. So I need to go 4 more. So 2001, 2002, 3, 4, 5. Should I do one last?
I put 9.37 for N.
I got 10.37.
I think it should be 10.37. Did you remember to do your exponent as n minus 1?
That would be it.
Yeah, that would be the quickest thing I could probably think of. Yeah, hold on. I'm just trying to make sure I mathed right. So plus 4. So 1 plus 4. I think it should be 2005. I think I just counted wrong. But remember, the n value is saying this is the year number that it's going to happen. So it's going to happen not in the 10th year, but in the 11th year after we start. So you're just finding the year that's year 11, which should be 2005. Because if 2001 is 7.
I have a really quick question.
Yeah. Yeah.
So is it the 11th year because it's like 0.37, so that extra makes it become 11? Okay.
Yeah, because if we did our if we did our equation, our a sub n, and we plugged in 10, we wouldn't get 4.1. We would probably get like 4.1 million. We would probably get like 4.07 million. So it wouldn't exactly hit 4.1 million in after 10 years. We would have to go one more year in order for it to hit the actual 4.1 million.
Okay, that makes sense.
Yeah.
Thank you.
Yep, you're welcome. Good question. Any other questions? Okay, so I think our next question that someone asked was, so we did day 6, we did day 7, we did day 8, day 9, problem 6. So day 9, that's today's, and I forgot what number it was, 6. Okay. Okay, so I'm not doing this one for you. I will give you guys some hints because since it's the only one that you guys have, I definitely want you to try it on your own, but I will give you guys a hint about this one. All right, so it's a geometric sequence. All right, so we know that in a geometric sequence, to find your common ratio, you take the second term, you divide it by your first term. All right, some of you guys are just looking at it and you can kind of guess the pattern, like what are we multiplying by? But other times you probably can't. Like if we're multiplying by like a fraction every time, you may need to actually set it up. So for this one, remember to find that common ratio, right? So to find R, we're going to take the second term and we're going to divide it by the first term. Well, that's not the only rule. Like you don't have to use the first and the second term. You could also do the third term divided by the second term. And that should also give you your common ratio. So any term divided by the previous term is going to give you your common ratio. So that's what you have to do to set this up. So you would say, okay, well, to start it, my second term is x plus 3 divided by my first term, which is x. And that should be equal to my common ratio. Well, I can also find my common ratio by doing the third term divided by the second term. And my third term, x plus 7, divided by my second term, which is x plus 3. And your goal here is to find x. So I think I've given you guys a lot, but you will definitely see one of these on the checkpoint tomorrow. So make sure you can solve it from this piece right here. Okay, those were all the questions that people had actually asked. Looking over stuff, is there anything else that you guys want to talk about from this week's material? Oh my God, yes. I just peeked over at your chat. I'm sorry. You guys don't have no idea what I'm talking about. I need to go to Khan Academy.
These are so weird.
Yeah. Oh my goodness. Okay. So the last thing I want to talk about, since there seems to be no other questions on this week's material, I want to talk about a couple things from last week's checkpoint that people kind of collectively maybe got not correct, like not right. All right, hold on, let me pull it up real quick. So much so that you guys were emailing me telling me that my answers were wrong. I promise I definitely triple checked them before I did the things. Let's see, where are we at though? No,
Miss Lastly, Ian sent something in chat that you should check out.
Did he? Do I really want to see it?
It's like something about math.
Can you guys see it on my screen? It is not. It's just some weird song.
Oh, it is?
It's like these frogs.
We can't see it. You gotta play it.
I can't do that.
It's not Rick Astley, is it?
I don't know. It looks strange. I don't know. You guys send me some weird stuff. All right. I need to go to Microsoft Forms. Oh my gosh. No, go back. Sorry, I'm trying to pull the quiz. It's not liking me right now on this computer. Okay. I made my husband let me use his fancy computer screens, but it's not all set up for me. So, all right, this is not what I wanted. This is not right. Okay, so maybe sign out and then try again. Okay, maybe different. Maybe it's this one. Schools.org. Oh my God, stupid two-way verification. Okay, so go away. 1, 7. Okay. All right, please let me look at the questions now. Excellent. Okay, so the one that people seem to dislike the most was, all I know is the correct answer was 37. Nobody liked that one. There it is. All right, so it gave you this sequence. And hopefully you guys kind of figured it out, but I just wanted to go through it again with you so that I can make sure you know what you're doing. -6, -16, ... and then a sub n equals -3, 4, 6. All right, so it was this sequence right here, and I wanted you to figure out what n was. So this one is, oh, it's not geometric. It's, I mean, yeah, it's just arithmetic. So we're subtracting 10. So subtracting 10, subtracting 10. All right, so our common difference is -10. So then we have a sub n equals 14 minus 10 n minus 1. All right, and so then you just plug in a sub n, which is -346. And then work backwards and solve. I had so many people tell me that this one was, this was definitely the most missed problem on the thing. And a lot of people wanted it to be 36. So we'll just, I guess we'll just walk through. So it is definitely not 36. So 14, so that would be -10n plus 10, and then subtract. So that's going to give us 0, 1, 4, 5, 6, and then 3, and then equals -10 and plus 10. So subtract 10. So I don't know what mistakes you guys are making. I know some people kind of sent me their work. There was a couple of you guys that emailed me your work, and you started with the wrong term. I saw a couple of people start with 4 instead of 14. So then your n value was off. So then just divide by -10, and you get n equals 37. All right, so that should have been the answer for that one. Just be careful. I can also see people maybe adding.
I'm so bored.
I'm sorry, you're bored. I swear we're almost done. But yeah, so I get it. It's so hard. But yeah, so it should have been 37. I just want to do that one with you guys because it was the most missed one from last week's checkpoint. So yeah, I'm not going to do a playthrough of Doom. I'm sorry. All right. But yeah, so was there any more confusion on last week's checkpoint, knowing that you guys have another checkpoint coming tomorrow that you guys maybe wanted your questions like clarified or answered because maybe you didn't know what you were supposed to do for something?
I had a question about one about the divergent versus divergent.
Okay.
Just neither. I don't know which one it was, but I think it ended up being divergent. I think it was.
Okay, so the one that ended up being divergent looked like this. So, ooh, that was really ugly. So like this, and then it said negative, and then 5, n minus 1, and then n equals 1, and then infinity was up there. All right, and so this one had the options of diverge, converge to with the limit equaling 0, and then converge with the limit equaling 5. All right, so for this one, all right, if we plug in 1 for n, it's going to give us 5. If we plug in, or negative 5. If we plug in 2, it's going to give us negative 25. Plug in 3, it's going to give us negative 125. So our number is just growing exponentially, right? It's 5 that's being raised to a power that's going to keep getting bigger as we continue. This one has no limit. It's just going to go to positive infinity or negative infinity because it's a negative out front. All right, so this one, if you try and do like the Bobo Bodden eats DC, it works for this one, kind of, right? If you think about this one, the exponent is biggest on the top of our fraction because the bottom of our fraction is nothing, like it's something over 1, if you want to think of it that way. So the number is biggest on the top and it's going to keep growing exponentially. So we would say that this diverges because there's no one number that it's going to go to, and infinity doesn't count as a number. So this one would have no limit. It would diverge.
Thank you.
Yep.
I also had a question. I think it was the first one on the checkpoint of last week, but I couldn't. It was like I was confused if it was 11 or 10. I don't know.
So the checkpoints are in random order, so I don't know what question was your first one. Do you remember what it was about?
It was, all I remember is that it was a really big number, but it was 2 big numbers, and it was
okay,
sequence.
Yeah, so it was probably there was the one that had the biggest number was it said find the 12th term of the sequence, and the sequence was so I'm just going on the fact you said it was a really big number. So this one was the biggest number out of all of them from last week. So it was 1.
Was there another one that had like a big-ish number? Because I thought it was something where it's like you had to find like what term it was in the sequence. I think it might have been a working backwards one.
Well, the 2 working backwards ones, one of it was the answer. It was the one that I did kind of up here. This was the most missed question. So the answer was 37, and a lot of people picked 36 for this one.
Okay, that might have been it.
It might have been that one.
Maybe. I don't know. My memory's not very good.
Yeah, I don't know. If you, I think you could probably, I don't know.
If I figure it out, I can email you too.
There we go. Sounds good.
It works.
Yeah, you can always just email it to me. Yeah. Okay. Any other questions on the checkpoint from last week or stuff that we're gonna do that's gonna be on the checkpoint for this upcoming week? Just making sure we're good.
I have a quick question. Miss Leslie, so are we gonna have like tests or the checkpoints subbing in for that, or what's the end of each unit signify? Like, what's the signify of each unit ended?
Yeah, that's a good question. Hang on, let me, I'm gonna stop recording really quick because it sounds like we're pretty much done with that part. All right, so stop recording. Yeah, stop recording.